Let's see. I don't know. I'd be afraid to eat them. I would be afraid to eat them.
I'm gonna pick some pizza too.
Okay.
Nobody ever ate it. What about this? Ready, set to go.
Let's see.
This is Chloe's.
Yeah.
French fries and half-eaten bread. Chloe, yours?
Yes.
I'm gonna throw it out.
Okay. I'm back.
I know. Go.
Yeah. Yeah. Sorry about that. Yeah.
Let's see. Okay. So hopefully, guys, everybody else will join us here in a minute. I'm at home, and so we're all going to be doing this on Zoom today. I've got to. Maybe I'm in the wrong. Okay. I thought, okay, it's in progress. Okay. That's what I. All right. Get back over here. Okay. That won't work. Let me go back. Okay. All right. So everybody bear with me. The class is going to have to join with us because I'm at home, and we're going to go over the practice problems. I've just got to get them copied into OneNote. I thought I had them there. So bear with me a second, and I'm going to copy the practice problems. So everybody get their, those of you that are coming in from class, I want you to have your workbooks out. Get your workbooks out. We're going to go through the practice problems. And those of you that are in class, would you please let the sub know that that Aaron and Kirsten and Chance are with us in Zoom, so she doesn't mark them absent. So somebody in class make sure that the sub knows who's online at home, so she doesn't mark them absent. Okay. I can't pull the roster up here at the house. I'm having troubles with that. So the sub has to turn, the sub will turn the roster in for me. And what you'll need to have out is the practice problems. Okay, that's what we're gonna work on. And I've just lost my cursor again. Oh. So everybody just bear with me a second, but we are gonna go over the practice. Some of you have had questions about the practice, so that's what we're going to work on. All right, let's see, let me go back and get, all right. So did someone tell the sub to be sure and count those students that we see online present, not to count them absent?
Yes, we did.
Okay, thank you, Anakin. Okay, guys, I'm copying these practice problems because we're gonna go over these. I've got to put them in the OneNote so we can work on them. So just a second. Lesson 1, practice A. Okay, so let me get these people in with this. Welcome to class, guys. Just be patient for a second. I do have a plan.
You know, when I first looked at this, it like instantly Black Friday, like Shoppers, Walmart. For example, Walmart, like those big dogs are the doors, and those are the little dogs are the shoppers. Like, get out of my way! I want a free TV. Like that's like, yeah, first instant Black Friday. Yeah.
So are you going to be talking? Chloe?
Yes.
Okay.
Oh.
Okay. So those of you that are in class, we're going to work through the practice problems. The last time we were together, that is what you were supposed to have completed. Plus, some of you have not turned in the cool down, okay? So you need to do that as well. So let me see how many I've got. Anakin, is everybody in now?
I believe so.
Okay. All right. Thank you. Now, guys, if you have questions as we go along, just put it in chat, okay, like someone just did. I wasn't here Monday. Okay. So, in Google Classroom. Okay. All right, so we're going to look at number 1, okay? All right, looking at number 1, it says, let me see, I got a question in chat, so let me stop right there. Okay, all right. It says, here is a rule to make a list of numbers. Each number is the sum of the previous 2 numbers. Start with the numbers 0 and 1, and then follow the rule to build a sequence of 10 numbers. Okay? All right. So, just a second, guys. I thought I was ready. Okay.
Hey, Nikki. Sorry, Professor Nikki. So is the Project 1 sheets, is it going to be on your website?
Let's see.
Okay. Oh, I haven't checked. I was just asking. Yeah. I was just.
Okay. I'm trying to find my, where did that come
Gotcha.
from?
Gotcha.
Okay. I'm here. Okay.
Okay. Thank you. Yeah.
All right. So we have 0 and 1. Okay. So can someone share their 10 numbers? Just type it in chat. What would the 10 numbers be? Okay, someone is going to share with us. All right, thank you, Kirsten. Okay, can everyone see that? Kirsten's is correct. What you're doing each time is you're adding the 2 previous to get the next one. Okay, so Grant, thank you for showing yours, but what it should look like is what Kirsten has. Okay, good job with your effort and being willing to show. Okay, but what you're doing is you're adding to the 2 previous, so that would be 1, then add the next 2, and 2, 3, 5, 8, 13, 21. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that would be 34. Okay, so let me see. Someone put comments in the chat. Tyler, okay. All right, good. That's correct too. The second one, not the first one, but the second one. That's good. Okay, all right. So does everyone understand how we got that sequence? If you don't, just put a comment in the chat. Okay, the rule was the sum of the previous two numbers in order to get the next one. Okay, and again, this is a sequence. We're following that rule to get the next number. Okay, all right, so moving on. Number two, let me raise this up a little. They give us 1/2, 1/4, 1/8, okay? They want you to give the rule, that follows, that's, that makes up this sequence. Did someone figure out the rule? Okay. All right, that's right, Grant. That's right. Keep halving the numbers. You're correct too, Tyler. Okay, good job. That's correct. And what you're doing is you're multiplying or taking half, or you could say 1/2 times 1/2 gives me 1/4, and then gives me the 1/8, okay? All right. If you're taking half, it's the same as multiplying by 1/2, because if you're dividing by 2, when you take half, you actually multiply by the reciprocal. So let me make sense of that. Taking half is like saying 1/2 divided by 2, which ends up being 1/2 times 1/2. Okay? All right. Says follow the rule and write the next 3 terms. What did y'all get for the next 3 terms? Okay. Just a second, my cursor won't let me look at my chat. Good. 1/2, 1/4, 1/8, and yes, 1/16, 1/32, and 1/64. That's correct. Okay. So let me, 1/2, 1/4, 1/8, and that's correct. Okay. Anybody have questions over 2? Okay, question 3. Now this is the one that has given some people some trouble. What I want to do first is write out the rule for you. Okay, so here's the rule. It's -2n, okay, plus 3. That is the initial sequence rule, okay, when you're going forward. All right, so the 4th term is -7, okay, it's -7. You have to find the next 3 terms, okay? Does someone have that? Well, my cursor is acting up. Okay. I didn't understand this one, but I got -11, -19, and -28. Okay. All right, that's a good try. Tyler, good try. Let's see, Georgia, 17, negative 31, and 65. That's correct. And Cole, you're close as well, but not correct. So Tyler and Cole, you're not correct. Georgia's correct, but let me show you, okay? All right, let me go back down here and get back where I was. My cursor is acting crazy on me. Okay, so they gave you the fourth term. So what you had to do was plug it in. -2 times 7 plus 3 would give you -14 and, okay, how did they get, see, 17, oh, -7, sorry, my bad, that's a -17. So let me put that back in there. So yes, it would be 17. Okay, then this would be 17. And then -2 times 17 plus 3 would give you the -31. And then -2 times -31 plus 3 would give us positive 65. Now, here's where it gets tricky, okay? Letter B, going backwards. All right, you're taking this function rule, but you're doing the opposite, okay? So the first thing you would do would be add 3. No, not add 3, subtract 3, sorry. It's the opposite. Okay, -3, and then divide by -2, okay, to get the first 3 terms. Okay, so you're going to start with -7. Does someone get that? Okay, Cole got -1, 4, and 5. Okay, and Georgia got 2, -1, and 5. Good job, Cole, for trying. You're close, but Georgia, you did get it correct. And let me show you why, Cole. Okay, so we're going to start with -7. -7, and then -3 gives me -10, and divide by -2 is 5. So 5 would go here. Then you do the same thing again. 5 minus 3 is 2. Divided by -2 would be -1. So this would be -1, and then plug that in. -1 minus 3 is 4, it's -4. Divide by -2 to get 2. So it's 2. So this one is 2, -1, and 5. Now I know that's confusing, but you had the original sequence up here. If I can find my pen. Right here's the original sequence. It was going this direction when we solve it. But when we go backwards, you have to do the opposite, okay? Going backwards, opposite operation, opposite direction. So -3 first, then divide, okay? Anybody have questions about that one? Okay. All right, so number 4, we have a sequence that starts at 0 and 5. It says give a rule and that you could follow in the next 3 terms. Okay? What did someone come up with? Okay. All right, very good, Grant. Tyler. Okay, Cole. Those would all work. Okay. Cole, I'm going to come back to yours in just a minute. Since Grant and Tyler have the same rule, I'm going to use that one for a second. Okay, so Grant and Tyler said n plus 5, okay, which would be correct. We'd have 0 and 5. Now, can someone give me the next 3 terms? Okay, Tanner has that. Anakin, that's correct. Okay, good. Grant, 10, 15, and 20. Okay. All right. So that's correct. 10, 15, and 20. Okay. All right. Now on letter B, it says give a different rule using the same sequence and the next 3 terms. Okay, let's see what. Put a 0 between the numbers. Well, okay, that's really not a sequence. Okay. Tyler, the reason why it's not a true sequence because there's really not a common difference. You're just adding a 0, you're just putting the 0 in. Okay. So, but good try though. Grant, and let's see, Cole, I was going to look at yours that you gave earlier. You said add 6 minus 1, and Grant says n plus 1 times 5. Okay. All right, so let me write Cole's. It's n minus 6. Let me see what no, add 6 minus 1, sorry. Add 6. Add 6 and minus 1. So put in 0 plus 6 is, so that would give you 0, 5. Then if you put 5 in, 5 plus 6 is 11. 11 minus 1. Okay, so we're still going to get the 10 and 15 and 20. But let's see what Grant's does. Grant gave us, let's see.
Well, when I first looked at this, the one on the left reminds me of Friends because it's like black and white. You can have white friends, black friends, and they're like talking to each other. While on the left, yeah, or the right, sorry, with the black line, white line. Okay, and that reminds me of The Enemy because it's like.
I'm sorry, guys. My daughter's quarantined too.
Them to get in line with one another, and it's like they're marching down an army or something like that.
Grant, can you tell us what your answers were? Okay, so he got 30. Okay, so he did 5 plus 1 is 6. 6 times 5 is 30. 1, so 30 plus 1 is 31 times 5. That's correct.
Do y'all have coronavirus?
No, we're
That's good.
no, we're being quarantined because we've been tested. We don't We have no results. So don't spread rumors, okay? I shouldn't have said that. I just wanted y'all to know what you were hearing was Chloe is here with me. Okay. All right. So everything okay with you guys? Do you understand? Anybody have questions about these practice problems? All right. Now, if you haven't done the cool down, you need to do the cool down, okay? If you haven't done the cool down, you need to do the cool down. Now, I want to go to Google Classroom and let me show you. Okay. Oh, I'm in the wrong Google Classroom. Let me get to the right one. Okay. Let's see. Let me go up here. Okay. All right. So this video, okay, right here, that's the next thing you're going to do. All right. Let me go ahead and go back. I want y'all to watch that video and it may stop and ask you questions. No, this one doesn't, but I do want you to watch this video and then I want you to come back and work this Edpuzzle arithmetic sequence. That one will, it's a video, but it will ask you questions. But let's watch this video. If I share it, everybody watch with me, okay? I'm gonna pull it up and y'all just watch with me.
Combine the terms that I can combine a 12 and a negative 10, and what I get is 10n plus 2. So
Wait.
they are the same. It's just this one here.
Let me start from the beginning. Sorry.
This lesson is all about arithmetic sequences. So to start off, this is an example of an arithmetic sequence, 12, 22, 32, 42. And what makes it arithmetic is the fact that the terms have what's called a common difference. So if I look at how do I turn a 12 into a 22, well, I have to add 10. And I have to add the exact same 10 to turn a 22 into a 32. And then a 32 into a 42, I have to add 10. This number here is called the common difference, and it is what all arithmetic sequences have in common. So if I want to verify that a sequence is arithmetic, what I have to look for is that common difference. It's always the same number every single time. Okay, that's what makes it arithmetic. And this is the common difference, not a common ratio. Geometric sequences have common ratios. Arithmetic ones have common differences. All right, and with these sequences, I can do many things. I can first write a recursive rule for it, just like I do for the geometric ones. I have to have my start with value, which is 12, and then I have to figure out what procedure I have to do to get the next term. So a sub n plus 1 is equal to the previous term, a sub n, and in this case, just a plus 10. So the only difference with these recursive rules is that I just have to change that multiply from the geometric to a plus in an arithmetic one. Now, what's interesting about arithmetic sequences is writing the apparent formula for them. And I'm going to show you a different way of thinking of this sequence that will help you see how to write the apparent formula for an arithmetic sequence. So we're going to start off by rewriting each of these terms. So a sub 1 is 12, a sub 2 is 22, a sub 3 is 32, a sub 4 is 42, right? We know those numbers, but I want to think about where 22 comes from. And 22 comes from me taking the previous term, 12, and adding 10 to it. And then 32 comes from 12, and then I have to add 10 twice to get there. And 42 is 12 plus 10 plus 10 plus 10. Well, what if I asked you for a sub 10? Are you going to write out 10 like that many times, like plus 10 plus 10 plus 10 plus 10? Heck no, that's too much. So what I want to do is I want to think about how can I rewrite this 10 plus 10 plus 10? And I need to think about what repeated addition is. Well, if I repeatedly add the same number over and over again, it's the same thing as a multiplication. So if I look at this, this is really 12 plus 10 times 3. And I go back and I think, well, this is really 12 plus 10 times 2. And this is really 12 plus 10 times 1. And this first one is really 12 plus 10 times 0. So if I want to figure out what a sub 10 is, I can write all this stuff out if I had the time, but I don't. So I'm going to rewrite it as 12 plus 10 times something, and then I'm just going to follow the pattern. So the first term had a 0, the first term or second term had a 1, the third term had a 2, and the fourth term had a 3. So what's happening with these numbers here is that it's really this subscript number, a little stage number, minus 1. So what goes here is a 9, because that's a 10, so I have to take 1 away, and I get 12 plus 10 times 9. And if I want to go to like some really huge number, like 5,432, I can write all those 10s out. I don't have the time. So I'm going to say 12 plus 10 times, well, what number? Well, it has to be 1 less than this. So it's 5,431. Now, to write the apparent formula, all I need to do is change this into an n. So I have a sub n equals, and then I'm going to do the same thing here. It starts with a 12 plus a 10. And then what do I do to the stage number, or the index here, to get this number here? Well, subtract 1. So I'm just going to subtract 1 from there. And this is how I write apparent formulas. Now, if you think about an arithmetic sequence, they all work this way. They have some number they start with, and they have some number they add over and over again. And the only thing that changes is this number and that number, but this is going to stay the same every single time. So if I want to come up with a formula to write the apparent formula for any arithmetic sequence, I just have to translate this into the variables. So I know that 12 in this case is a sub 1. So I know that a sub n is going to equal to the first term, a sub 1, plus this 10. Now I need to think about, what is that 10 to the problem? Well, the 10 was the common difference. So I'm going to pick a letter for common difference. I'm going to pick D for difference. So then I put a D there. And then what goes in parentheses? The stage number minus 1. So this thing here is the formula that you would use to write the apparent formula for any arithmetic sequence. First term plus the difference times the stage number minus 1. So let's see this with a couple of other sequences. So let's look at, for example, 55, 48, 41, 34, 27, dot, dot, dot. First, let me verify that it's arithmetic. So to go from 55 to 48, I have to subtract 7, subtract 7, subtract 7, subtract 7. So this is arithmetic. Now, if one of these numbers is off, like if I made a typo or something, and it ends up being like minus 6, then it's not arithmetic and this does not work. These numbers all have to be the same. And since they are, this is our common difference. Our common difference in this example is going to be negative 7. And the sign makes a difference, because if your common difference is positive, your sequence values go up. But these obviously go down, so I have to have a negative common difference. So if I'm going to write the formula for it, it's a sub n equals first term, 55, plus, and then common difference, negative 7, and then n minus 1. And this will give me that sequence if I substitute n for 1, 2, 3, 4, and 5. Okay, now I can also write it like this. I can write 55 minus 7 times n minus 1, because we know that the definition of subtraction is adding the opposite, so I can combine those two signs and to just get this sequence here. Let me do another one. This time let's look at a fraction, just to see that you can do this with fractions too. So if I have the sequence negative 1/4, negative 1/2, negative 3/4, negative 1, dot, 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 I can see going from negative 1/4 to negative 1/2, I am subtracting off a fourth, and then I'm subtracting off another fourth, and then I am subtracting off another fourth. So I know it's arithmetic. The common difference is negative 1/4. And so if I want to write the apparent formula, it's start with the first term, which is negative 1/4. I'm going to add the common difference, negative 1/4, and I'm going to subtract, or I'm going to multiply it by n minus 1. So that's the apparent formula for this one. Now, this is not the only way to write an apparent formula. There are many ways to write an apparent formula, and I'm going to show you one other way. And this is how I think of it personally. Whenever I write these rules, this is how I think of them. And I'm going to go back to the very first one. 12, 22, 32, 42, 52, dot, dot, dot. Now, I know this thing has the repeated addition. And I know the shorthand way of writing repeated addition is to multiply. So I know that the apparent formula has to have some 10 times an n. So 10n. I know 10n is part of it, or 10 times n is part of it. But the thing is, that doesn't work. If I think about 10n, 10n by itself generates a 10, 20, and then 30. But if I look at these numbers and I compare them, I see that these numbers are all short by 2. So if I just take this rule and I add 2 to it, I can get the sequences to match up. So I can always take this common difference and take it and multiply it by the n, and then just figure out what I have to add and subtract to make it work. Now, this rule is exactly the same as the other rule, but just not simplified. If I remember what the other rule was I started with 12 and I did 10 times n minus 1. Well, if I follow the order of operations and I simplify this thing to get rid of the parentheses, I multiply 10 times n and I get 10n, and then 10 times negative 1, which is minus 10 plus 12. And if I combine the terms that I can combine a 12 and a negative 10, and what I get is 10n plus 2. So they are the same. It's just this one here hasn't been simplified down. And this one uses the patterns in all arithmetic sequences. And this one, I just kind of have to like try to figure out how it's working.
Okay. So that was just a additional instruction about arithmetic or arithmetic sequences. Let's see. So, all right. So what this assignment up here is about is you'll watch a video and answer questions, okay? So today, what I want you to do is finish the cool down and watch this video. And I'm going to quit sharing, but I'm going to stay online and y'all can ask me questions, okay? Anyway, let me go in here. I'm going to stop sharing my screen. Oh, someone was had a question. Let's see. What if there's not a common difference? Okay. If there's not a common difference, or if there's not a common ratio, then it's not a sequence. And we're going to see some of those. There'll be some of those that they'll throw at us, but so if it does have a common difference, and we're going to talk about in the next section, the geometric sequence, and that's where it'll be a common ratio. So, but if it doesn't have one of those, then it won't be a sequence. It'll be like the one, Tyler, that you shared with me earlier, where you had 0, 5 and threw in a 0, 6 and so forth. Okay. All right. So you guys right now, y'all go ahead and finish those assignments, and I'm going to stay online to where you can ask me questions. Does everybody know what they need to work on? If you don't, just ask me a question, okay? If you do, go ahead and get started. Where's the cool down? Okay, the cool down is in Google Classroom. Okay, it should be Algebra 2, Unit 1. Yes. Okay. Lesson one. Cool. Let's see. Cool down. Yes. If you want to leave Zoom, that's fine. But if you need to send me a question, ask me a question, somebody will need to stay on Zoom to do that. So now, if y'all all get done with that assignments, then work on something else. Okay? Anakin and Bo, y'all might share that. If they get done with everything that I've asked them to do for today, they need to work on something else. Don't sit there and visit. I mean, if you know what you're doing, it's fine to get out of Zoom and y'all can just send me an email.
Did you just get done with class?
Well, I'm still in.
Okay.
Is that your teacher?
Mm-hmm. Sorry, it was just like Paula talking, the dad talking, you talking, and then she was trying to talk. It was, okay. Yeah, but it's okay. And I just feel overwhelmed.
I know. I know, that's how I feel too.
Have you seen Miss Edgar's post
No,
of like what she does? I want to call in so I can just do homework, but I don't want to call in.
they've already had somebody call in today.
Exactly. Yeah. And did you see my text?
Yeah,
Yeah, like I would take it, but that's when I have class. Yeah. I mean, do you think that was okay?
mm-hmm,
I mean, Carla's not mad.
no,
I kind of feel bad because Bailey said that's her day off. What time is your next class?
at 1:30.
Oof. Well, I got done with my last class of the day. I mean, I would have been, but Dr. Riley said just practice your shorties. I was like, okay. I mean, I think I clock in at 5.
Oh, not 2?
No. Oh, wait. No. That on 1. Yeah. Wednesday I clock at 5, and then Friday I clock in at 5:30. But I told Carla that I was gonna be late, but you know what? It's fine. I just feel bad, but I can't help it about the shift. I mean, Carla already asked me if I want to work Labor Day. I was like, yeah, that's fine. I mean, it's 9 to 2 or 9:30 to 2:30. Is that like 5 hours?
Yeah, 5 or 6.
5 or 6. Dad asked me, like, Chloe, is this yours? I'm like,